Hello students, welcome once again to our channel Score High to Soar High. In this video series, we have been learning about the derivations pertaining to lesson 1 electrostatics of class 12 physics of Tamil Nadu State Board syllabus. Actually, this is the 8th derivation in this series. Come on, let us move on to the derivation. Before that, don't forget to subscribe and share it with your friends. The 8th derivation is electric field due to charged infinite plane sheet. Before learning this derivation, let us learn a small concept called aerial vector. Here comes a square-shaped area, a surface, and I am going to place a metallic rod of this kind perpendicular to this surface. Now, this metallic rod represents the aerial vector. So what is meant by aerial vector? Any vector which is drawn perpendicular to any surface is known as aerial vector. By keeping this concept in mind, let us derive the derivation. Now, have a close look at this diagram. Here comes a infinite plane sheet which is positively charged, and we are going to find the electric field due to this infinite plane sheet. For that purpose, let us imagine a Gaussian surface which is in the shape of a cylinder. So this is the cylindrical Gaussian surface which passes at the center of this plane sheet. Now let us take three regions. One is this circular region, and another one is this circular region, and the third one is this curved surface of this cylinder. Let this region be P and this one be P dash, and here also I have taken a small surface. Now, this is the center of this plane sheet, and I am going to calculate the electric field at this point P. So the distance in between this center and this point is nothing but small r. Now, let me take a small surface, this small circular surface over here. So let it be dA, and a vector which is perpendicular to this small surface is nothing but dA vector. And again, what is the direction of the electric field due to this charged plane sheet? It directs both in this direction and also in this direction. So in this direction, this E vector represents the direction of the electric field due to this plane sheet. Now, what about this E vector and dA vector? They are in the same direction. So the angle in between them is nothing but 0. Similarly, at this point P dash also, here I have taken a small surface, so let this surface be dA, and the aerial vector which is perpendicular to this surface is dA vector, and again in this direction the electric field direction is this. So this is the direction of the electric field, so I have written E vector. Again in this case, both E vector and dA vector are in the same direction, so the angle in between them is 0. Now in the third case, I am going to take a small surface over this curved surface of this cylindrical Gaussian surface. So let this surface be dA, and a vector which is perpendicular to this surface is dA vector. This dA vector is actually the aerial vector of this surface. So this is the direction of dA vector. And what about E vector? As usual, in this direction, the E vector is pointing from left to right. So this is the direction of the E vector. In this case, E vector and dA vector are perpendicular to one another. So the angle in between them is nothing but 90 degree. So by keeping all these things in mind, let us derive the derivation. Now, according to Gauss law, pi E is equal to surface integral of E vector dot dA vector is equal to Q by epsilon naught. Either we can write Q enclosed or just Q by epsilon naught. It doesn't matter. Now, what is the surface integral of E vector dot dA vector? This is equal to integration of E vector dot dA vector at the curved surface plus integration of E vector dot dA vector at the point P plus integration of E vector dot dA vector at the point P dash. Now let us calculate at the surface P. As we have already learned, at the surface of P, E vector and dA vector are parallel or along the same direction. So theta is equal to 0 degree. So in the next step, integral of E vector dot dA vector at P, which is equal to integral of E dA cos theta. How does it come? You might have learnt in mathematics, A dot product. A vector dot B vector is equal to AB cos theta. Similarly, E vector dot dA vector is equal to E dA cos theta. That's how it has come. In the next step, which is equal to integral of E dA cos, in the place of theta I am going to place 0. So in the next step, integral of E dA, what is the value of cos 0? 1. So we have got integral of E dA at point P. In the next step, this electric field is constant in this case, so we can't integrate it. So let us take it out. So I am going to integrate only dA at point P. What if I integrate dA, I will get A. This is the integration formula. Integration of dx is equal to what? X. Similarly, integration of dA is equal to A. That's what we have got here. So which is equal to E into A. Now at the surface P dash. Here also E vector and dA vector are parallel. So theta is equal to 0. So no need to do all the steps. We can write therefore integration of E dash E vector dash dA vector at P dash is equal to what we have got in the previous case EA. The same thing we can write it here also EA. Now we are going to find out the integration at the curved surface. Here as we have already learned, E vector and dA vector are perpendicular to each other. Therefore here theta is equal to 90 degree. So let me write the equation. Integration of E vector dot dA vector at curved surface, which is equal to E dA cos theta. Hope you would have understood this concept. A vector dot B vector is equal to AB cos theta. Similarly, E vector dot dA vector is equal to EDA cos theta at curved surface. In the next step, which is equal to integration of EDA cos 90 degree at curved surface. So cos 90, what's the value of cos 90? Which is 0. So integration of EDA in the place of cos 90 I have written 0. So on the whole, finally, what do we get? We get 0. Now let us substitute the values of these three terms in the previous equation. Therefore, pi E is equal to 0 plus EA plus EA. 0 is at curved surface and EA at point P and EA at point P dash. Therefore, pi E is equal to EA plus EA 2EA. Let this be equation number 1. And as per Gauss law, we know that pi E is equal to Q by epsilon naught. Let this be equation number 2. Now, compare these two equations 1 and 2. In these two equations, the left hand sides are equal. Therefore, the right hand sides must be equal. So, from equations 1 and 2, let me write 2EA is equal to Q by epsilon naught. 2EA is equal to Q by epsilon naught. Therefore, E is equal to Q by 2A epsilon naught. In the next step, what have I written? E is equal to epsilon by 2. E is equal to sigma by 2 epsilon naught. From where do we get this sigma? Actually, sigma is equal to Q by A. Sigma is nothing but surface charge density, which is equal to charges per unit area. Q stands for charge and capital A stands for area. So here in this equation, Q by A is there. In the place of Q by A, I have substituted this sigma, which is nothing but surface charge density. So on the whole, this is the final expression for this derivation. Capital E is equal to sigma by 2 epsilon naught. With this derivation has come to an end. Let us meet in the next video with another derivation.
Like, share and comment and subscribe our channel and click the bell button for more videos. Thank you.